Good morning, children. Let's continue our work on inverse trigonometric functions. Today we are going to prove some of the identities. I am going to take up 3 identities in a group. Out of 3, I will prove 1. You will work on the remaining 2 proofs. Always remember the thing which I have told you. To prove inverse trigonometric functions, or when we work on inverse trigonometric functions, we refer back, we use trigonometric functions. So, if I take this first group of identities, then you understand all these intervals given are based on the domain and range of these inverse trigonometric functions. So, like sine inverse of 1 by x is cosec inverse of x. X is greater than or equal to 1, less than or equal to minus 1. This is same as, this interval is same as r minus 1, 1. You remember we had listed it for the range of cosec inverse. Therefore, all these intervals are given accordingly. Now, if I take up the second one to prove, yes, so as we discussed, for cosec inverse of 1 by x, I assume it to be y, right? That means 1 by x is cos y, right? Inverse trigonometric statement I transferred into trigonometric statement. That gives me x is 1 by cos y, and 1 by cos is sec y. So when x is sec y, so y is sec inverse of x. Now what was y? Cos inverse of 1 by x. That means we have proved that cos inverse of 1 by x is sec inverse of x. Proved. Did you understand? Questions are easy to work on it. And inverse trigonometric, we assumed this to be y. Then what did we do? 1 by x is cos y. We shifted this as trigonometric function. And then we got x as 1 by cos y, which is sec y. And we got the identity. Similarly, you will take this as y and work to get this. You will take this as y and work to get this. And that completes your first group of identities. Coming to the second group of identities, if I look at this, sine inverse of minus x is minus sine inverse x. Now look here, x belongs to minus 1 to 1, domain and range. I am very keen in discussing this interval. This is modulus of x is greater than or equal to 1. If I draw the number line, it's nothing but this is minus 1, this is 1. Modulus of x is greater than or equal to 1. That means all these numbers and all these numbers will come. That is, this is same as r minus 1, 1. It is just a different expression they have given. So, modulus of x greater than or equal to 1 is nothing but r minus 1, 1. So, if I have to prove this identity, I take suppose this, the third one. So, what I do is cosec inverse of minus x be say y. So what do I have? X is equal to cosec of y minus x equal to. So x is minus cosec y. Yes. Now all of you, x is minus cosec y. Cosec of minus theta is minus cosec theta. So that is cosec of minus y. Right? So you have this x is cosec of minus y. That means cosec inverse of x is minus y, or y is minus of cosec inverse of x. Yes. Now what was y? Cosec inverse of minus x is minus cosec inverse of x. We have proved this identity. Again, understand one thing, sine of minus theta is minus sine theta. Same way cosec of minus theta is minus cosec theta. I have used that class 11 Trigo, right? So cosec inverse of minus x we assumed as y. That gave us minus x as cosec y. So x becomes minus cosec y. Minus cosec y is cosec of minus y. And then you have cosec inverse of x as minus y. So y is minus cosec inverse x, and we proved the identity. Now I have proved the third. First and second you are going to work on your own, right? Also this third group of identity we are going to work. Here if I take, now you understand these intervals. If I take this first part, cos inverse of minus x, add say y, that gives you minus x as cos y. So x is minus cos y, and you understand it is cos of pi minus y, and therefore you will get pi in all these identities. So you have cos inverse of x is pi minus y, and you put that cos inverse of x is pi minus cos inverse of minus x. Just shift the terms and you get the identity. That is the third group of identities. That means in all 9 proving questions, 9 identities I have discussed in this class, on which you are going to put in lot of efforts. Yes? Bye.